You think you know Saturn, the pretty planet, the one with the rings, the one that looks like a toy sitting in a cheap backyard telescope. You have seen the pictures. You have probably used one as a screensaver at some point. But before this video is even 2 minutes old, I need you to understand something. Saturn is not pretty. Saturn is not a toy. Saturn is one of the most violently extreme, genuinely strange environments in the entire solar system. And for decades, it was hiding its worst secrets in plain sight, until the James Webb Space Telescope finally looked directly at it and found things that left scientists completely speechless. Things no planet should be able to do. Things with no explanation. Things that forced researchers to rewrite what they thought was even possible inside a planetary atmosphere. This is what Webb just revealed. And by the end of this video, you will never look at Saturn the same way again. Let's start with scale, because Saturn is not just big, it is big in a way most people never fully absorb. It is the second largest planet in our solar system after Jupiter, with a diameter roughly 9.5 times that of Earth. If you hollowed Saturn out and started filling it with Earths, you would need about 760 of them before it was full. Its equatorial winds blow at speeds exceeding 1,000 kilometers per hour. That is not a typo. The fastest wind ever recorded on Earth during a hurricane was around 400 kilometers per hour. On Saturn, that speed is not a storm. It is the permanent, everyday baseline, more than double Earth's worst hurricane, blowing constantly across the entire planet. Now let's talk about Saturn's North Pole, because this is where things start to get genuinely disturbing. Sitting at Saturn's North Pole is one of the strangest natural structures ever discovered anywhere in the known universe. It is a storm, enormous, permanent, and utterly relentless. But unlike every other storm ever observed on any planet, it is not circular. It is a perfect hexagon, a six-sided geometric shape built entirely out of clouds and gas, rotating around Saturn's pole for as long as we have been able to observe it. Over 40 years now, since the Voyager flybys of the early 1980s. Let that sink in. A geometric shape sitting in a planetary atmosphere on a planet the size of Saturn. The hexagon spans roughly 20,000 miles across. Earth's entire diameter is about 7,900 miles. This single storm is more than twice as wide as our entire planet. Winds inside it travel at roughly 300 miles per hour, and the eye of the cyclone at its center is 50 times larger than a typical hurricane eye on Earth. 50 times. And it has been sitting there, rotating, holding its perfect six-sided shape for over 4 decades. Scientists have pieced together an explanation involving jet streams, fluid dynamics, and resonance patterns in the atmosphere. But even with that explanation in hand, the hexagon remains one of the strangest single objects in the entire solar system. Here is the key thing you need to understand about the hexagon before we get to what Webb actually found. Before Webb, scientists could only study the hexagon's visible layer, the lower clouds you can literally photograph with a camera. They could see its shape. They could measure its winds. They could watch smaller storms churn inside it. But what was happening above the hexagon, up in Saturn's stratosphere, and further still in the ionosphere, the electrically charged plasma layer capping the very top of the atmosphere, was almost a complete mystery. The emissions from those upper layers are extraordinarily faint, far too faint for ground-based telescopes and too faint even for earlier space telescopes to resolve. Nobody had ever seen what was actually happening up there in any real detail. Then Webb pointed its near-infrared spectrograph at Saturn's North Pole and stared, continuously, for 10 straight hours, not 10 minutes, 10 full hours of uninterrupted observation, watching Saturn rotate beneath it the entire time. The instrument was tracking infrared emissions from a specific molecule called H3+, a positively charged form of molecular hydrogen that plays a central role in the chemistry of Saturn's upper atmosphere. Think of it as a tracer, a natural beacon that lights up in infrared light and lets scientists map chemical and physical processes in layers of the atmosphere that had simply been invisible before. What came back from that 10-hour stare shocked every single scientist on the team. In the ionosphere, the uppermost electrically charged layer, sitting roughly 1,000 kilometers above Saturn's nominal surface, the team saw something that had never once been observed on any planet anywhere in the solar system. Embedded inside the bright, glowing auroral halos ringing Saturn's North Pole, like dark spots scattered across a glowing ring, sat a series of strange, dark, bead-like features. Distinct, separated dark patches arranged inside the bright aurora like a necklace of shadows floating high above the planet. These dark beads held their shape and position across the entire 10-hour observation. But when scientists compared data from different time periods, the beads appeared to slowly drift over longer stretches of time. Nobody knew what they were. Nobody had seen anything like them before. Existing atmospheric physics had no explanation for them. The lead scientist on the study, Professor Tom Stallard of Northumbria University, leading a team of 23 researchers spanning the UK, the United States, and France, put it about as plainly as a scientist ever will. He said these features were completely unexpected and, at present, completely unexplained. That quote, taken from a peer-reviewed paper published in Geophysical Research Letters in August of 2025, is about as significant as it gets in science. When researchers who have spent entire careers studying a planet's atmosphere look at new data and call it completely unexpected and completely unexplained, that means what they are seeing genuinely does not fit anywhere inside our current understanding of how that planet works. But the dark beads were only the first shock. About 500 kilometers lower, in the stratosphere just beneath the ionosphere, Webb's instrument picked up something equally strange and arguably even more visually striking. Inside the methane emissions of Saturn's stratosphere, the team found a star-shaped pattern radiating outward from the North Pole toward the equator, a shape that appeared to have 6 arms, matching the 6-sided symmetry of the famous hexagon far below it. Except when they looked closely, something was clearly wrong. Only 4 of the 6 arms were actually there. 2 arms were simply missing. The star was lopsided, broken, asymmetric, its 4 remaining arms extending from the pole in a pattern that lined up with some, but not all, of the hexagon's 6 corners beneath it. When the team overlaid their maps of the stratosphere and the ionosphere against the known position of the hexagon deep in the lower atmosphere, they found something even more extraordinary. The star's arms in the stratosphere pointed directly above the corners of the hexagon, far below. And the darkest of the bead-like features in the ionosphere lined up directly above the strongest of those stratospheric arms. Structures separated by hundreds of kilometers of altitude, sitting in completely different layers of the atmosphere, appeared to be somehow linked despite the enormous physical distance between them. As Professor Stallard put it, the team had expected broad, diffuse bands of emission in the upper atmosphere. Instead, they found fine, delicate patterns of beads and stars that, despite sitting hundreds of kilometers apart in altitude, may somehow be interconnected, and may also be tied directly to the famous hexagon deep in Saturn's clouds. Sit with what that actually implies for a moment. If these structures really are connected, then the hexagon at the bottom of Saturn's atmosphere is not simply a weather pattern confined to the clouds. It may be influencing or being influenced by processes happening hundreds of kilometers above it, reaching all the way up through the stratosphere into the ionosphere. Some kind of vertical coupling, some exchange of energy or information appears to be occurring across multiple, completely separate layers of the atmosphere simultaneously. Nothing like this has ever been observed on any other planet we know of. Not Jupiter, not Uranus, not Neptune, not Earth. If your jaw is somewhere on the floor right now, go ahead and hit that like button, because we are only halfway through what Webb found, and the next part solves a mystery that has haunted planetary scientists for over 40 years. Since Voyager 1's flyby of Saturn in November of 1980, scientists have been trying to answer a question that sounds deceptively simple. How fast does Saturn actually rotate? You would think you could just watch a feature go around and time it, but Saturn made that remarkably difficult because unlike Earth, it has no solid surface at all. It is a gas giant all the way down, with no mountains, no landmarks, nothing fixed to track. So scientists relied on radio emissions tied to Saturn's powerful magnetic field and aurora as a stand-in for its rotation. Voyager 1 measured a rotation period of roughly 10 hours and 40 minutes. When NASA's Cassini spacecraft arrived in 2004 and measured the exact same signal, using the exact same method, it got a different answer. The period had apparently lengthened by about 6 minutes. And it kept changing in the years that followed, shifting again and again, as if Saturn's rotation rate itself was somehow fluctuating over time. That is an enormous problem because a planet cannot simply change how fast it spins. Something like that would require a massive transfer of angular momentum with no plausible physical mechanism behind it. Planets do not randomly speed up and slow down, at least not on the timescales these measurements were suggesting. So either the measurements were wrong, or something genuinely bizarre was happening at Saturn. For 4 decades, scientists argued over which one it was. Webb finally answered the question. A 10-hour observation from November of 2024, published in the Journal of Geophysical Research, Space Physics, in March of 2026, revealed the truth. And the truth turned out to be more fascinating than almost anyone predicted. Saturn's rotation was never actually changing. The planet had been spinning at the same steady rate the entire time. The measurements were wrong, but not because of instrumental error. They were wrong because of something happening inside Saturn's own atmosphere. Here is what was really going on. Saturn's aurora, its version of Earth's northern lights, forms when charged particles funnel down along the planet's magnetic field lines and slam into the upper atmosphere. That collision heats the atmosphere most intensely, wherever the aurora burns brightest. That localized heating drives powerful atmospheric winds. Those winds, moving through the charged plasma of the ionosphere, generate electrical currents. Those currents alter the exact auroral emissions scientists were using to measure Saturn's rotation, producing a false reading every single time. But it does not stop there, because those same currents flow back through the system and power the aurora all over again. The aurora heats the atmosphere drives the winds create the currents power the aurora, and the entire cycle begins again. A self-sustaining planetary heat engine running continuously, powered by nothing but Saturn's own magnetic field and its northern lights, quietly producing the exact electrical signatures that fooled every instrument pointed at Saturn for 40 straight years. Professor Stallard called it simply a planetary heat pump. In his own words, Saturn's aurora heats its atmosphere, the atmosphere drives winds, and the winds produce currents that power the aurora, and so it goes on, feeding itself indefinitely. For decades, we knew something strange was happening with Saturn's apparent rotation, but had no explanation. Then we learned it was being driven by atmospheric winds, but still did not know why those winds existed in the first place. This single set of observations, made possible only by Webb, finally closed that loop. A 40-year mystery solved by 10 hours of the right instrument pointed at exactly the right place. Now, step back and think about what all of this actually means together. Saturn is not some distant exoplanet circling a star light years away. It is right here, a few doors down in cosmic terms. Humans have studied it with telescopes for over 400 years. We sent Cassini, a billion-dollar spacecraft, to orbit it for 13 years, from 2004 to 2017. We genuinely believed we had a solid handle on what Saturn is and how it works. And then Webb looked at it with a sharper eye than anything that came before. And in a single 10-hour observation, it found dark beads nobody knew existed, a broken star pattern nobody had ever seen, apparent connections spanning hundreds of kilometers of altitude that no planetary model predicted. And it settled a rotation argument that had been running since the 1980s. This is exactly what makes Webb so extraordinary and, honestly, so humbling. It keeps showing us that even the planets we have studied for centuries still hide profound secrets, just below the resolution of what we could previously see. Saturn's dark beads in the ionosphere remain unexplained. Why exactly 2 arms of the stratospheric star are missing is still unknown. The precise mechanism connecting the hexagon far below to the structures hundreds of kilometers above it is still being worked out. Webb answered some long-standing questions and opened up an entirely new set that scientists are only just beginning to investigate. There is something even deeper worth sitting with here. Something about why Saturn specifically, out of all 8 planets, keeps surprising us in ways no other world quite manages. Jupiter is larger. Jupiter has its own storms, its own magnetosphere, its own complex atmosphere, but somehow Saturn keeps producing phenomena with no parallel anywhere else in the solar system. The hexagon alone makes it unique. No other gas giant has a persistent geometric storm at its pole. Jupiter has an oval. Saturn has a hexagon. That asymmetry alone has kept planetary scientists busy for decades. And even with the broad mechanism now understood, its stability across more than 40 years inside a turbulent, wind-shredded atmosphere remains genuinely remarkable. Then there are the rings. From a distance, they look almost impossibly delicate. Up close, they are something else entirely. Saturn's ring system stretches outward roughly 282,000 kilometers from the planet's center. Yet, in most places, the main rings are only about 10 meters thick, made mostly of water ice mixed with rocky debris, in particles ranging from grains smaller than sand up to chunks the size of houses. Within them are waves, spirals, clumps, gaps, and dark spokes of material that appear and vanish, shaped by the gravity of Saturn's dozens of moons and changing even on human timescales. Webb has studied the rings too. In infrared light, they transform from their familiar pale appearance into a glowing blue, because the water ice they are made of reflects infrared extremely well. In 2024, Webb and Hubble observed Saturn together 14 weeks apart, letting scientists slice through the atmosphere at multiple altitudes simultaneously. That combination produced the most detailed, three-dimensional portrait of Saturn's atmosphere ever assembled, revealing clouds and hazes at different depths, temperature gradients, and chemical reactions happening at nearly every altitude. Saturn is not one atmosphere. It is dozens of distinct environments stacked on top of each other. And then there is the moon system. Saturn has 146 confirmed moons, more than any other planet in the solar system. Titan, its largest, is bigger than Mercury, with a thick, nitrogen-rich atmosphere, lakes, rivers, and seas filled not with water, but with liquid methane and ethane, raining from an orange, smog-covered sky. Scientists consider it one of the most promising places in the solar system to study chemistry connected to the origin of life. Then there is Enceladus, a small ice-covered moon hiding a global liquid water ocean beneath its frozen crust, kept liquid by tidal heating from Saturn's gravity. Through cracks near its south pole, that ocean vents geysers of water vapor and ice into space. And Cassini flew directly through that plume, finding water, salt, carbon dioxide, hydrogen, and organic molecules. Essentially every basic ingredient life on Earth depends on. Whether microbial life could exist in that ocean remains one of the most serious, actively debated questions in astrobiology today. If any part of this, the rings, the moons, the hexagon, the impossible aurora, genuinely blew your mind, subscribe to this channel and turn on notifications right now, because Webb is still only just getting started with Saturn, and I want you here for whatever it finds next. All of this, the rings, the moons, the hexagon, the dark beads, the broken star, the self-sustaining auroral heat engine, the 1,000-kilometer-an-hour winds, exists within a single planetary system, well within reach of our telescopes and eventually our spacecraft. Saturn is not one discovery. It is a solar system within a solar system, and Webb has peeled back several of its layers in just the past year alone, essentially as a side project, since its primary mission is aimed far beyond our solar system entirely at exoplanet atmospheres, distant galaxies, and the dawn of the universe itself. Saturn is simply one stop on a schedule that spans the entire observable cosmos. And yet, even in passing, Webb is quietly transforming everything we thought we knew about our nearest giant planetary neighbor. Now imagine what we might find if an entire mission were built specifically to study Saturn with Webb-class instruments, a dedicated Saturn orbiter combining Webb's infrared sensitivity with Cassini's proximity. That mission does not exist yet, but the data Webb has already sent back is quietly building the scientific case for exactly that kind of future mission. We sent Cassini to Saturn and spent 13 years in orbit, coming home with enough science to fill entire libraries. We turned Webb towards Saturn for just 10 hours, and it found phenomena nobody had ever seen and nobody can yet fully explain. If 10 hours can do that, what could an entire decade of dedicated observation reveal? Whatever the answer is, it is almost certainly something nobody would predict today, because that is simply what Saturn keeps doing. The planet that looks like a toy in a backyard telescope, the planet everyone points to as the prettiest one in the sky, is also a world of geometric superstorms, self-sustaining atmospheric heat engines, broken star patterns drifting through charged plasma, dark beads floating through auroras 1,000 kilometers up, winds that make Earth's worst hurricanes feel like a gentle breeze, and a moon system holding at least two of the most promising places in the entire solar system to search for life. Scary is not quite the right word for it. Magnificent, terrifying, and endlessly surprising, that is Saturn. And James Webb has only just started looking. Before you go, tell me in the comments below. Out of everything Webb found here, the dark beads, the broken star, the 40-year rotation mystery finally solved, which one genuinely surprised you the most? And if this video changed the way you think about Saturn even a little, share it with someone who still thinks it is just the pretty one with the rings. It takes 10 seconds, and it is exactly how a story like this reaches the people who need to hear it. Because the next time someone shows you a photograph of Saturn and says, "Look how pretty," you will know exactly what is really happening inside that image. Behind those beautiful rings, inside that golden atmosphere, above that perfect hexagon, dark beads drift silently through an invisible ionosphere, a broken star floats through the stratosphere in a self-sustaining loop of heat, lightning, and wind has been running without interruption since long before humans ever existed. Webb is watching all of it, recording all of it, helping us understand one extraordinary discovery at a time just how strange and just how alive this planet really is.